Alrighty, we are going to take a look at some of our vocabulary for three-dimensional shapes today. But first, Nurse Julie's calling me. Please wait. Okie doke. Thank you for your patience. So we are going to take a look at three-dimensional shapes vocabulary. Okay, we are also going to be taking some notes on that vocabulary. So your notebook with the 3D shapes that we took on Monday, make sure you have that with you because we're going to be adding to that today. Okay. Alrighty, first things first, your vocabulary can be found on your Seesaw activity titled 3D Shapes Vocabulary Day 1. 3D Shapes Vocabulary Day 1. Go ahead and hop on there for me, please. You will see your success criteria on slide 1. Your success criteria is your goal for the day and you being able to identify how you know you were successful. Here is your goal.
This week in math, we will start a new topic in geometry. We will identify and describe the following: a cube, sphere, prism, pyramid, cone, and cylinder. Today we're going to focus on a few of these 3D shapes: the cube, the prism, and the pyramid. We are going to describe these shapes using vocabulary like vertices, edges, and faces.
Okay, vertices, edges, and faces. That is going to be your new vocabulary for today. This is a video that you watched, but we're going to watch it again and complete these sentences. An edge is, a vertex is, and a face is. Okay, and we're talking about geometry, so saying this right here isn't going to cut it, friends. We're talking about shapes, okay? All right, let's take a look at this together, and we will discuss our definitions of our words when this is finished. And skip.
Three-dimensional or 3D shapes are shapes that take up space. They have 3 dimensions: length, width, and height. The world is made up of 3D shapes. They are all the things we can hold. Your book is a 3D shape. So is your soccer ball, as well as your birthday presents. Can you see how they each take up space? There are some features that are common across 3-dimensional shapes. These features include faces, edges, and corners. The flat surfaces of a shape are called faces. No, not that type of face. The edge of a 3D shape is the line where 2 of its surfaces meet. And the corner is where 2 or more edges meet. A corner can also be called a vertex. The faces of 3D shapes often contain 2D shapes that you may already know. Maybe you can recognize some of these 2D shapes as we go through a few examples. Here are some 3-dimensional shapes and their features.
All right, we're going to pause right there. You've just heard what a face, edge, and vertice are. We're going to take some notes on this now. If you would please get your math notebook. Go ahead and go to that page about 3D shapes that we started on Monday. We are going to add those 3 definitions to our notes. The first word that we are going to add is face, F-A-C-E. E spells face, and that's me. Face. Okay. A face is a flat surface on a shape. A face is a flat surface on a shape. Camille, camera on. So on the cube that we drew here, we see 6 different faces. The front of the cube and the back of the cube are 2 faces. We have the top of the cube is another face. The bottom of a cube is a 4th face. The left of the cube is a 5th face, and the right of a cube is a 6th face. Okay, so faces are flat surfaces on a shape. Those surfaces might be any different shape. I'm going to go ahead and shade in because I'm using different colored pens. If you're using pencil, don't, because it'll make it confusing. But my face, so we can color coordinate, is here. Next, we have an edge. And this is not the kind of edge around your hairline. This is an edge that applies to a shape, okay? An edge is where 2 faces touch. An edge can be found where 2 faces touch. Make sure you are writing this down in your notebook. I'm seeing a lot of friends just sitting and staring. We are writing this down in our notebook. So an example of an edge on our cube can be found here. This is where 2 faces touch. The top face and the front face are touching along this line segment. So edges are often line segments. Okay, so typically when you see a line segment on a 3-dimensional shape, that is an edge. Our final word is a vertex. Vertex is a fancy word for corner. A vertex is the corner of a 3D shape. Corner is the longer definition that we will write because a corner is also where at least 2 faces touch. You know what? That was a lie. That's 3. It's where at least 3 faces touch. Okay? So a vertex would be found here on the corner of this cube because the bottom face, the front face, and the left face are all touching here at this point. And we call that point a vertex. Okay. William, your hand is up. I'm not sure if it's from earlier or for something now.
That's from earlier.
Gotcha. So these definitions will help you count and determine how many faces, edges, and vertices are on the 3-dimensional shapes that we're going to talk about today. Okay. I will take a picture of this and upload it to Seesaw so that you have it in case you are at a different location than your notebook, or if you did not have time to finish, you will get time to finish during your independent work time. But those 3 definitions are what we need today. A face is a flat surface on a shape. An edge is where 2 lines, 2 faces touch. A vertex is the corner of a 3D shape where at least 3 faces touch. Alrighty. So again, this is uploaded to Seesaw. We're going to come back together and use these definitions to determine the number of faces, edges, and vertices on shapes that we see on Seesaw. Let's take a look at slide 3 together, please. Slide 3 asks us to identify the edges in red, vertices in green, and the number of faces in blue. We see here the answers. There are 6 faces. Let's go ahead and highlight those in red. There are 8 vertices. Let's go ahead and highlight those in green. And there are 12 edges, which we've been asked to highlight in blue. Oh, I did that backwards. No, I didn't. Yes, I did. Goofy me. There we go. The faces are supposed to be in blue. Oops. There we go. And the edges are supposed to be in red. Okay. So it says to identify the edges in red. Let's go ahead and trace the edges. Okay. Get a red highlighter or a red pen, whatever you prefer. And we are going to trace the edges of this cube in red. An edge is where 2 faces touch. So this is an edge. The top face and the front face are touching along this line segment. you'll notice there are 4 edges along the top of this cube. It is where the top and the sides meet. So that's 4. We are told there are 12. So let's continue to trace these. We're going to also trace the edges that are going down this cube all the way around. So there are the 3 that we can see, and then there's the one in the back that is in that dotted line segment. So now we have 4 on top, 4 going down the side, so that's 4, 8. And then we also have 4 edges going along the bottom, where the bottom and the sides meet to form edges. So we have now traced 12 edges, or 12 line segments. Yes, Leah.
So if you look at it, it's basically just all squares, but it's making another shape.
Yes, the edges have traced squares, and that will help us identify the faces. Very good connection. So now we're going to identify the faces, okay? I'm going to get a highlighter, and I'm going to make this my largest dot. I want you to use a highlighter, not a pen, because a pen will cover the faces, and it'll just look like a big blob. The highlighter you can see through. So grab the highlighter. We're going to trace the highlighter in blue. Okay, get a big old fat dot highlighter. Okay, let's go ahead and shade the top face. So there's face 1 along the top. Boop. Let me get a little bit of a smaller dot to go in there. Doop, doop, doop. There we go. We've got face 1 along the top. Then we're going to shade the front face. So that's one face. Here's the second face on the front. You got to kind of use your mind's eye here to move the shape in your brain so that you can trace each or shade each face. We've got the top, we've got the front. Yes, Leah.
If you look at it another way, we actually just shaded 3.
Yes.
Beside.
Yep, that shading is going to start to overlap itself and we'll be able to see. So we've got the top, we've got the front. We're going to do this part that we can see over here, which is the right side. That's another face. Another word for these shapes, we often say side. The mathematical term is face. So we've got the top, we've got the front, we've got the right side. Let's now trace the bottom. Look at the bottom here. It's got 2 dotted lines. Now look, ooh, it's getting darker because it's overlapping. So that is now a 4th face. Now look at the back of your cube. It's got 2 dotted line segments and 2 solids. That is a 5th face. And then along the left, it's still light blue. That left side is that sixth face. So we've thought about each side or each face of this cube. There are 6. A lot of geometry when you're looking at drawings is imagining in your brain and flipping it so you can see all aspects even though you're looking at a standalone image. Okay. Now we're going to look at the vertices. For the vertices, I'm going to go ahead and switch to my pen. I'm going to get a nice size dot. I'm going about medium. And I'm going to put a dot on each vertice. Remember, the vertices are the corners of 3D shapes where 3 faces meet. So we see 4 corners or vertices up top. 1, 2, 3, and 4. You can see the line segments that are connected to each vertice. So this vertice here has the front going down and going back towards the back of the shape, all connecting. We also see the bottom vertices. 1, 2, 3, 4. So we have 8 total vertices. Are there any questions about faces, edges, and vertices right now? Okay, let's take a look at slide 4. Slide 4 has a video for us to watch first. I want us to take a look at faces, edges, and vertices so we can get them in our mind.
Woo!
Oh, goodness. And go.
Hello, Kiket. Today, we are learning about the rectangular prism. How many faces does a rectangular prism have? Let's count together. 1, 2, 3, 4. 4 around, 5 on the top, 6 on the bottom. It has a total of 6 faces. Look at the faces of your rectangular prism. What shapes can you see? Do you see rectangles? What about squares? How many edges does a rectangular prism have? Let's start with the front. 1, 2, 3, 4. Now count the number of edges at the back. 5, 6, 7, 8. Almost done. We just have to count the side edges on the top and the bottom. 9, 10, 11, 12. The rectangular prism has 12 edges. What about the number of vertices? Let's count together. 1, 2, 3, 4, 5, 6, 7, 8. It has 8 vertices. I think you are ready to make a model of the rectangular prism. Go and get the toothpicks and Play-Doh.
Alrighty, that's an activity we'll do at another time. Right now, we're going to continue taking our notes. Okay, it says identify the edges in red. So we've got our edges here in red. There are 12 of them. Our vertices in green. There are 6 of them. And our faces in blue. There are also 6 of them. These numbers are the same as a cube. The difference is instead of being all squares, we now see rectangles. Okay, so let's go ahead and get these faces done. Our faces here, we can see the very front face. 1, The right side face, 2. The left side face, 3. See how I'm kind of turning it in my mind's eye, just like that video did for us? The top face, 4. The bottom face, 5. And then the back face, 6. So again, we can see where all 6 faces are by turning it in our mind's eye to imagine where the places are. Then we're going to take a look at the edges. The edges are going to be in red. Go ahead and grab your red pen. Let's trace those edges. We've got the 4 that go around the front rectangle. The top, the right side, the left side, and the bottom. This shows us the outlines or the edges of the front face. Then we're going to go ahead and take a look at the back and do the same thing. These edges are going to overlap on the 2-dimensional plane. We've got the left side and the right side. Maybe, here we go. We've got the top of the back edge. We've got the bottom of the back rectangle. Woo, that looks trippy. Then on the left side, we have these squares. There's the top and the bottom. We've already outlined the side of those. So we have 4 on top, 4 on the bottom, 4 on the left side, and then we have the left and the right of the other side. So that again is all 12 line segments. We also see our vertex, our corners. Let's go ahead and get a green dot. I'm going to get a medium-sized dot. They've already been outlined for you. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Any questions on that? Jalen. Go ahead and unmute, Jalen. We can't hear you. There you go.
Why did you have to color the whole shape?
So that's showing the faces. It's showing the sides of the shape. I was showing you each part. It does look like it's all shaded one shade because we've touched each part of it, but each of those was a different square. Okay?
Okay.
All righty. want you to take a look at slide 5. On slide 5, you are going to look at this video about the triangular pyramid. These ads are killing me.
Five, 6, 7, 8. The total number edges that a pyramid has is... What is that number again? Correct! It's 8! Can you count the number of vertices? I think you can do it. You ready? Go! It's time to make a model. Do you have your toothpicks and Play-Doh? If you have them in hand, you can start making it. Can the pyramid roll like a ball, or it can only slide? Give it a test and find out. Try stacking a pyramid on different shapes. What have you found out? Do you notice you can stack a pyramid on top of shapes that have flat surfaces, but you can't stack shapes on top of the pyramid? Tomorrow, you will need a cone-shaped object, a pair of scissors, and glue.
Previews for what we're going to be doing here soon. You'll be doing another supply pickup, but for right now, that should help you be able to manipulate and move around the faces, edges, and vertices of a triangular pyramid. So we see a triangular pyramid here. And again, we are going to identify the edges in red. There are 6 of, ooh, yep, that should say 5. Oh, it does say 5. Ooh, that's a weird 5. I don't like that 5. Let's make it better. 5. Oh, that's a terrible 5 too. 5. There we go. 5. Let's say edges. No, that is right. There are 6 edges. That's why I was confused. Faces is what I was confused about. For faces, there are actually going to be 5 faces. So this needs to be crossed out. So our faces is in blue, and there are 5 of them. We'll highlight those together. 5 faces. And then our vertices are going to be in green, and there are also 5 of those. Okay, so let's take a look here. Let's get these vertices out of the way first. Our vertices are where each of the 3 faces might meet. 1, 2, 3, 4, and 5. Go ahead and trace those. Our edges, let's go ahead and do those now. Those are going to be in red. And our edges are the 3 on this triangle on the front. 1, 2, 3. We have 2 more on the triangle on the right. 1, 2. Oops. 2 more on the triangle on the back that is in a dotted line segment. And then 1 more on the bottom square base. I'm going to redo those vertices so that I can see those a little bit better. And then we can do our faces. I'm going to switch to a highlighter, and I'm going to shade that bottom square face first. 1, 2, 3, 4 edges around that bottom square. And then we have our front triangle, 1, 2, 3 sides or edges around that front face. Our right triangle, 1, 2, 3 edges around that face. The back triangle, 1, 2, 3 edges around that face. And then on the left side of our triangle, 1, 2, 3 edges along that face. So we can see again that there are 5 faces, the 4 triangles and the 1 square. Yes, Aiden G.
Did you know that it looks like a wedge?
It does look like a wedge. Now you know why we're teaching 3D shapes and simple machines at the same time. Good connections. Alrighty, and then on to slide 6. This is our last one that we're going to do together. This is about a prism, okay? Now, prisms are different from the other shapes that we've watched because prisms can come in many different shapes. I want you to take a look at what I mean by watching this video. All the different types of prisms that are available.
Kids, today we will learn some more interesting 3D shapes. That is, prism and pyramids. Let's start with learning. What is a prism? In simple words, prism is a 3D shape in which the top and bottom faces are the same shape and size, and all the other faces are rectangles. I will repeat. Prism is a 3D shape in which the top and bottom faces are same shape and size, and all the other faces are rectangles. There are many types of prisms depending upon the shape of its top and bottom faces or its cross section. Let's see. First one is the triangular prism. This is a triangular prism because its top and bottom faces are triangle in shape, and all other faces are rectangular. It has 6 vertices, 9 edges, and 5 faces. Now, let's learn another type of prism. This is a square prism. This is a square prism because its top and bottom faces are square in shape, and all other faces are rectangular. This is the same as a cuboid. So it has 6 faces, 8 vertices, and 12 edges. Now, let's learn another type of prism. This is a rectangular prism because its top and bottom faces are rectangular, and all other faces are rectangular too. This is the same as cuboid shape. So, it has 6 faces, 8 vertices, and 12 edges. Now, let's learn another type of prism. This is a pentagonal prism because its top and bottom faces are pentagon in shape, and all other faces are rectangular. It has 10 vertices, 15 edges, and 7 faces.
Okay, So it's the same and same and same. We can keep adding shapes. We can have a hexagonal prism. We can have a octagonal prism. The definition of a prism means that the top and the bottom are the shape. So right here we see triangle, triangle. So this is a triangular prism because the rest are rectangles, okay? Today, for your independent work, I want you to complete the remainder of these slides by filling in the name of the three-dimensional shape and the number of edges, vertices, and faces. You are also going to do the same shading and highlighting in red, blue, and green that we just did together. Okay, so Leah, do you see these directions right here about highlighting? Awesome. So identify the edges in red, vertices in green, and number of faces in blue, okay? You are also, and this is a fun part, going to find 2 pictures of real world examples of this 3D shape. So on Google, you can go to your image search, get to Google Images here, and under images, I'm going to search for this shape, which is a cube. I just gave you an answer. Cubes. I'm going to go to images and I'm going to find cubes in the real world. I see a Rubik's Cube is an example of a cube in the real world. Ooh, this is an LED cube. That's another one. And I can take these images and place them on my Seesaw assignment. If you'd like to be more specific, you can put cubes real world, and that will bring up a variance of different types of cubes. Presents, dice, boxes, ice cubes, sugar cubes, concrete, okay? So this will bring up different examples, and you're going to screenshot those examples and place them on Seesaw. This assignment will take you a lot of time because there are 1, 2, 3 things to do on each slide, and you have 1, 2, 3, 4 slides. So that means you have 12 things to do. This will take you some time, but it's a lot of fun in using some of your art skills. Okay, so that is your assignment for today, in addition to the success criteria, which I know you guys know.